Hey guys, this is question MM414 of the Maths Methods Fortify study guide. So we've got this function which is a hybrid function f of x equals a cos of pi x on 2 from 0 to 1 and then 0 elsewhere. Now our question says that we need to show that a equals pi on 2. Awesome. So first things first is to recognize that whenever we have a continuous probability density function, the area under this function must equal 1, okay? Because the area under the function corresponds to the total probability of the event. So therefore we know that the total probability has to be equal to 1, which means that the area under that graph equals 1, okay? Which means that our area, so the integral from 0 to 1 of a cos pi x on 2 dx is equal to 1. Okay, so now we can just evaluate this as normal, right? So we've got this one unknown a, and as we go down the line of the working, we'll be able to see that a becomes solvable. So how do we integrate this? Well, we can take this cos, and we can integrate that into sine, okay? But we also have to take this coefficient of x and do 1 over that, all right? So what we end up with is a over pi over 2, and that changes to a sine, and then the pi x on 2 stays exactly the same how it is, from 0 to 1, okay? And this is still equal to 1. Now, a over pi over 2 is the same as 2a over pi, right? Because this 2 comes up here. 2a over pi sine pi x on 2 from 0 to 1, that's equal to 1. And then what we get is 1 equals, now we can sub in our values for 1 and 0, so we get 2a over pi sine of pi times 1 over 2 is pi over 2, minus 2a over pi sine of pi times 0 over 2 is 0. Awesome. Now, just going back up here. We get 1 equals, sine of pi on 2 is 1. So we get 1 minus 2a on pi times sine of 0, which is 0. So we get 1 equals 2a over pi, which means that pi over 2 equals a, as required. Now our first mark comes when we integrate this, and our second mark comes when we state that a equals pi on 2. You can even say at the end as required, or QED, and that kind of, you use it whenever you're showing something, and then at the end you say as required, as I was meant to find. Cool, so a equals pi on 2 is our final answer for part A. Let's move on to part B. Part B is a 3-mark question this time. So what we're given, or what we're asked, part B, 3 marks. What we're asked is to find the probability that x is greater than or equal to 1/2, given that x is greater than or equal to 1/3. Okay, so we need to find that. Awesome. So first things first is to recognize what this actually means. So according to our conditional probability formula, the probability of a given b is equal to the probability of a intersect b over the probability of b. So we need to use this same concept within this function here, or within this problem here. So in that case, we know that the probability that x is greater than or equal to 1/2, given that x is greater than or equal to 1/3, is equal to probability that x is greater than or equal to 1/2 intersect x is greater than or equal to 1/3 over probability that x is greater than or equal to 1/3. Awesome. So in that case, we now need to find the intersect between x is greater than 1/2 and x is greater than 1/3. Now if you can think about this on a number line, we've got 1/3 here and 1/2 here. Now we've got this x is greater than 1/2, so everything above here, and x is greater than 1/3, which is everything above here. And what's the common ground? Everything from this point onwards. So everything from x is greater than or equal to 1/2. So we can say that our intersect point there is same as probability that x is greater than or equal to 1/2. Then that's over x is greater than or equal to 1/3. Awesome. That's actually our first mark. Now we need to figure out the probabilities of each of these things happening. So how do we do that? Well, we know that the probability in a continuous density function is equal to the area under the graph within those areas or within those terminals. So what we're looking for first is the probability that x is greater than or equal to a half, right? So what we're looking for is the area above 1/2. So our lower bound is 1/2, our upper bound is naturally 1 because that's the upper bound of our function, which means that we get 1/2 to 1. And we know that a from the previous question is equal to pi on 2. So our function is pi on 2 cos of pi x over 2 dx. Awesome. So now what we get when we integrate this, we get pi on 2 over pi over 2, because we take this coefficient and we put it under that, sine of pi x on 2, so that stays the same, from 1/2 to 1. Now pi on 2 divided by pi on 2 is just 1, so our final function is sine of pi x on 2 from 1/2 to 1. Awesome. I'm actually going to go back up the top now. So, awesome. So now what we get is equal to sine of, we're going to sub in our 1 for x, so we get sine of pi times 1 over 2, minus sine of pi times 1/2 over 2, which is pi over 4. Awesome. Sine of pi on 2 is 1, and sine of pi on 4 is root 2 on 2. So therefore, the probability that x is greater than or equal to a half is 1 take root 2 on 2. Now, we have to do the other one. So we have to do our probability that x is greater than or equal to a third. So again, we do the same process. So our area from 1/3 to 1 of pi on 2 cos pi x on 2 dx. Exactly the same process, so we know that our integrated function is still going to be the same, so sine of pi x on 2 from 1/3 to 1. Subbing this in, we get sine of pi on 2, so we sub our 1 in, then we minus subbing our 1 on 3 on, which means we get sine of pi on 6. Sine of pi on 2 is 1, sine of pi on 6 is 1/2, so therefore we get 1 take a half, which is 1/2. Awesome. This is our second mark right here. Now our third mark comes when we actually put it all together. So I'm just going to leave this bit here and this bit. So our probability that x is greater than or equal to a half, given that x is greater than or equal to 1/3, was equal to the probability of x is greater than or equal to a half over x is greater than or equal to 1/3. Now we found greater than or equal to a half to be equal to 1 take root 2 on 2 over the probability that x is greater than or equal to a third, which is 1/2. Awesome. Now what we're going to do is we're actually going to put all this together, because we don't have a calculator in this question, so we're going to have to do this by hand. Now, whenever we've got a whole number and a fraction inside a fraction, we want to create a fraction using this. Okay, so in order to create a fraction using this, as in one fraction, we're going to have to make the denominators the same. So we want this to have a denominator of 2, which means we're also going to need to times the top by 2. So we're going to have 2 on 2 minus root 2 on 2, and that's all over 1/2. This then becomes 2 take root 2 over 2, and then it's all of that over 1/2. Rearranging this, we actually get, what do we get? We get 2 take root 2 over 1, which is 2 take root 2. So our third and final mark, guys, is 2 take root 2. If you have any questions about any of this, just hit me up in the comments below. But that wraps up MM414, 414. Thank you very much for watching, guys, and I will see you in the next video.